did subatomic particle, atomic particles, atomic structure, whatever, yeah. This time I'm going to be doing amount of substance, which is a bit more calculative, so it might be harder for me to show you, but we'll try, we'll get over it, won't we? So we've already covered relative atomic mass, haven't we? So we know that. Oh, the MR, the relative molecular mass, I don't know if we've already done this, I can't remember, I've got a brain like a sieve. Anyway, the MR is basically you sum the AR values of all of the atoms in the formula. So yeah, if you've got like 2 sodium atoms and 1 sulfur, it'll be 2 times 23 plus 32.1, so it's quite easy. Moles, I hate moles. I hate moles, but yeah, it's something that we have to know. So 1 mole equals 6.022 times 10 to the 23. 6.022 times 10 to the 23, that's something you need to remember. The equation for finding moles is moles equals mass over relative atomic mass, or relative molecular mass if needs be. And if you put that into one of those triangles, you'll be able to find the relative atomic mass and the mass if you don't already know it. So yes, 12 grams of carbon-12 is 1 mole. So basically in chemistry everything goes off carbon-12. It's a really important atom. So we can think of a mole in 2 ways basically. So 1 mole of substance is defined as the mass of a substance that contains the same number of particles as 12 grams of carbon-12. The particles may be atoms, molecules, ions, or even like electrons. So as I said, 1 mole of carbon-12 has a mass of precisely 12.00000 grams because carbon-12 is a standard. And then the second way we can think about it is that 1 mole of a substance equals 6.022 times 10 to the 23 particles of the substance. And that number is called the Avogadro constant, which is also known as L, for some reason L, but yes, anyway. So yeah, that's moles in quite a bit of detail. Well, not much detail, but yeah. So I've just done loads of questions here about doing it, so you don't need to know that. So moles in the balanced chemical equation. So the reaction, this is one of the things that I've got written down here. The reaction equation shows the ratio of the number of moles and reactants and products. So say if you've got like 4x plus y equals 2z, you've got 4 moles of x. It basically, if you react 4 moles of x with 1 mole of y, you get 2 moles of z. And if you want 1 mole of z, you'd need to react 2 moles of x with half a mole of y. So yeah. Also, if you reacted 1 mole of x with an excess of y, the maximum amount of z we could produce would be a half moles because we've still only got 1 mole of z. 1 mole of x, sorry. I I've got some stuff highlighted here, so I guess you should know them. 1 mole of carbon, this isn't the highlighted part by the way. Right, so where are we up to? Right, key terms. An excess is basically, if one reactant is in excess, then the other reactant will react completely and it'll all be used up. If something reacts completely or disassociates completely or is completely oxidized, it means that all of the reactant will be used up in the reaction. And finally, a limiting reagent is basically the opposite of an excess, and all of the limiting reagent is used up in a reaction and then the reaction stops. Then there's lots more questions here. Then we go to reacting masses. The types of calculations that are here can usually be worked out by following the same series of steps and using that triangle that I told you. So the steps that you use is that you write the equation, you extract the information from the question, work out the number of moles of one substance, use the mole ratio to deduce the number of moles of something else, the other substance, and work out the mass. Then there's lots of questions. Lots more questions. Lots more questions. So moles in a solution has a different triangle, and that is moles equals concentration times volume. Now the volume needs to be in decimeters cubed, not centimeters cubed. And the concentration is in mole to the decimeters minus 3. And you can swap that about to get concentration equals mole over volume, or volume equals mole over concentration. Also, to get from centimeters to decimeters, you divide by 1,000 and vice versa for the other way. So, yeah. And there's lots more questions again. Volumetric analysis, basically titrations. It's used to find out the concentration of a solution. A titration is the method by which a solution of an acid is accurately added to a known volume of a base until neutralization just occurs. The titration will tell us the volumes of each solution which reacted, and the concentration of one of the solutions must be known before the titration. This is called the standard solution. You might be asked to do one of these for your practical exam if you have a practical exam. I was. It's quite common, so I'd learn about titrations. The concentration of the other solution can therefore be calculated, so yes. The steps to solve the titration problems, it's basically the same as the other steps, but I'm going to read it out to you anyway. It's to write the equation, extract the information, work out the number of moles, use the mole ratio, and work out the concentration. Then again, there's lots more questions. And we get to the ideal gas equation, which is very fun. The ideal gas equation is PV equals nRT, where pressure is P, pressure being in pascals, V is the volume in meters cubed, N is the number of moles, R is the constant, which is 8.31, and T is the temperature in Kelvin. To get from degrees Celsius to Kelvin, you add 273 to the first temperature. Then to get from centimeters cubed to decimeter cubed, as I've already said, you divide by 1,000. Then to get from decimeters cubed to meters cubed, you divide by 1,000 again. So therefore, if you need to get from centimetres cubed to metres cubed, you divide by a whole million, and vice versa for the way back. To get from pascals to kilopascals, it's divide by 1,000, and to get from kilopascals to pascals, you times by 1,000. One note on that: 1 atmosphere is equal to 100,000 pascals, if you're asked about that. Also, 1 mole of any gas has a volume of 24.3 decimeters cubed at room temperature. Don't know if you need to know that, although I know that now. So if you need to work out each of the things, volume equals nRT over P, basically just rearranging the equation. P equals, so pressure equals nRT over V, mole equals PV over RT, and T equals PV over nR. You get used to doing that really quickly, as you probably know. Forgot that you're doing the same course as me. So there's loads of questions, and then we get to molecular and empirical formula. Do we have time for this? No. I'm going to have to do another video on molecular and empirical formula, explaining the rest of the booklet. So
yep, I'll see if this video and have fun revising chemistry.